that has experienced a fish kill from lowered pH. From a look at it, it looks pretty desolate. Wasn't able to find the location of this, but that's one of the consequences of lowering the pH. One of the ways that aquatic ecosystems can be damaged when the pH is lowered. The organisms' life in the lake just aren't used to that. Okay, so something we've been talking about a lot: nitrogen and sulfur oxides, right? They just keep coming back. That's what we're worried about for acid rain: nitrogen oxides and sulfur oxides. From when it's coming from us, it's called anthropogenic. I always think about anthropology, right? Study of man, early humans. So anthropogenic from human sources, like here we have factories and houses, transportation. There is some from natural sources, just the decomposition of plants. But remember, that is not the problem. The earth has dealt with that for a long, long time. Those fish you just saw right here, they're not dead from natural plants decomposing. A lot of times politicians will try to throw that out there to confuse. Well, natural acid rain is natural. It happens naturally, which is technically true, but that's not what causes the problem. Just like climate change, they try to change it. It's global warming, but they want to twist it to say climate change because climate does always change. So then they have a little in with the argument. But the globe, the temperature in the atmosphere and the ocean is getting hotter and hotter and hotter. It's global warming. So more of that. And it leaks into the AP curriculum. But we need to be clear. So those sources, sulfur oxides, nitrogen oxides, drive acid rain deposition. We see here, this is a pretty car exhaust, so motor vehicles, combustion, right? Motor vehicle, probably better put a note to that because you can have a motor vehicle be electric car, it's not going to be producing that. However, right here, this is a coal plant. This is the main issue. Although I mentioned electric vehicles, they have to get their electricity from somewhere. So if it's getting electricity from a coal-fired power plant, it will be contributing to acid rain. So motor vehicle, coal burning power plants, acid deposition. Just basically deposition and deposit. You guys know what a deposit is, right? Same idea, same root. Okay, so again, these are mostly on the East Coast, and we're in Europe. Now, acid deposition affects communities mostly that are downwind. Could be 10, 20 miles, could be 100, 200 miles. So downwind from coal burning plants. Now, I found these really cool time-lapse studies. Here is a coal power plant. It looks like it's in Kentucky. And they took it over, July 2005, January 2005. So it took it during the summer and during the winter time. Just kind of look. The jet stream is moving differently. In the winter time, let me write that down. Winter time, it's kind of blowing east and then kind of north all the way to, let's see, Indiana. Let's see, Ohio is what's right here. This is Ohio, and Pennsylvania and New York is getting hit pretty hard right here. Okay, Michigan is kind of staying out of it. Indiana's getting hit a little bit, but Ohio is getting blasted by this power plant from Kentucky, and a lot of Kentucky is too. But in the summertime, it looks a little different. Now it's blasting the other side of Kentucky, and West Virginia is kind of covered up there. So it's pretty much messing up the state it's coming from, staying in Kentucky. And then the Carolinas are getting hit right there. And I think I have another from Texas. All right, so I believe this is the winter, and this is summer. Oh yeah. And we see where the patterns are slightly different depending on the season. But look at this. This is kind of going a little further than. Yeah, it definitely is further, right? Really making its way up until Illinois is right here. Missouri is getting hit really hard by this coal-fired power plant. But in the summertime, Louisiana, Mississippi are getting hit pretty hard. So acid rain doesn't stay in one place. These pollutants, wherever they go, typically downwind of any kind of a negative environmental source point. This would be called point source is also. That's a good thing to remind ourselves. Point source of pollution. And remember, point source versus non-point. Point sources can be easier to deal with in some respects because we know exactly where it's coming from. It doesn't move. It's easy to study. Non-point sources can be more difficult to pin down and harder to study. Oh yeah, here's another, I think from the same article. A really cool diagram showing how it's moving around. So this is the right along the Mississippi in the lower corner of Tennessee. Yeah, Tennessee, south of Memphis there. Seeing all that cold deposition actually going pretty even spread all around the city or the county there. Look at that creeping around, hitting what Arkansas and Missouri, but mostly Tennessee. Yeah, but I noticed they got all the way to Texas. All right, so things get acidified, the soils and bodies of water. There we go. And corrosion, basically breakdown of human-made structure. So here's a couple good ones that came up for me on my search of statues that have been damaged by acid rain. We put a lot of effort into our buildings. Especially we want to preserve those older ones, like from the Renaissance. Go to places in Europe, colonial Mexico, South America, the United States. We got some, not a whole lot, and acid rain really does a job, especially since a lot of these can be reactive with the acids. Hold on, there we go. So a lot of these statues are made out of limestone and marble, and those tend to be highly reactive with acid rain. Limestone, marble. So they react, make a little fizz, which is good in a way. When it fizzes like that, it's neutralizing the acid, but it's wearing away the actual face when it's doing it. So it reacts with sulfur oxides and nitric oxides. Okay, limestone and marble. They tend to be very, the pyramids, the Egyptian pyramids were covered with limestone because it's a real light color. It's like shiny, gleam. I don't know, it's not limestone now, the basic insides. Okay, so trees don't do well. Remember, H+, that's what we're talking about, acids. When we're thinking of bases, thinking about OH negative hydroxide ions. Anyway, here's a couple, sugar maple and red spruce. These are common on the East Coast. But what happens is calcium and magnesium get leached from the soil. There we go. 2 vital elements. And instead, aluminum is mobilized and taken up by the tree in that process. Okay, so acid degrades nutrients in the soil. That's the overall picture you need to think about. Nutrients in the soil. Okay, write that down. And you look at these trees, they're not healthy. They're not able to grow as well, to put on needles or leaves. Sorry, these are deciduous. So one of the main issues is they get decreased cold tolerance. Now, I'm not sure if they also have decreased heat tolerance. It must be a different mechanism. Therefore, when freezing does happen, they're more likely to be damaged. This right here is an example of what happens to your lakes if they get too acidic. This lake is in Sweden, and this is called liming the lake. Liming the lake. Okay, so basically calcium oxide, that's lime. So this is just dumped in the lake, and that to raise the pH. This is basically a base. And as we saw, if you have acids, if you add base, if you add OHs, it's going to raise the pH. This is like in the magnesium rainbow lab. We have the acidic, the vinegar, and then the base in the basic magnesium hydroxide will raise the pH. It'll kick loose these OHs to raise the pH. But it looks dramatic. Okay, so they just keep dumping this in, testing it to see if it works. But this is expensive, and it can cause other problems. So there are regional differences in soils and bedrock, of course. The rock isn't the same across the world. In some places where there's more limestone, you can have more neutralizing effects. Find better to neutralize. Okay, so where you have the limestone, you have that ability. So wherever you see high acid sensitivity, it usually means you don't have much limestone. We just saw Sweden doesn't have much limestone, therefore their lakes are more prone. But if you look here, Cascade Mountain's my favorite. Okay, going through Washington, Oregon, and part of Canada. Those can be sensitive. Luckily, we don't have coal-powered power plants. But the East Coast, you'll see sensitive, and they have a lot of acid deposition. But you see here, southwest, I mean. I believe that's from where we used to have more coal-powered power plants. See China, they used to use a lot of coal. They still do. And then the Koreas. Anywhere you have development, all of Europe, we saw before, has issues. Okay. But limestone helps neutralize that. This right here, there's a lot of famous, I had fun. There's a lot of famous limestone structures in the world. This is Malaga, Spain. Gorgeous. I want to go check that out. This is called Beachy Head in England. That's gorgeous. Look at that. Would you stand on the corner right there? right on the edge. England. Cliffs of Dover you may have heard about in Spain. I should put that in there. But yeah, this is calcium carbonate. Okay. Now, this is all seashells. Carbonate, that we talked about. Important for building those seashells. This right here, you've probably seen in the movies and pictures, these limestone structures. This one happens to be in Thailand, but you find these in different parts of Asia and China, Vietnam. big limestone plugs sitting out there in the ocean. I think they look really cool. This is at Phong Na Bay. Come on. There we go. Okay, so cool. But yeah, this is all limestone. All these things are limestone. So how could you design an experiment to test the effect of acid rain on plant growth? So independent variable, what you could do is, grow plants and change the pH of water you're going to water it with. Water for watering. Your dependent variable, what you're going to measure, perhaps the height of the plants, right? Maybe you'll measure the root mass. That's an important part of the development. Maybe let's see, the amount of chlorophyll made. And to do that, you would measure basically how green it is. Measure the green color. Okay, all indications of how well the plant is growing. If it's having trouble, like that lower pH, that acidic soil is making it difficult for it to get nutrients, probably won't have as much height or root mass or chlorophyll for sure. The control variable is everything else. Control variables. Everything else, types of seeds, the amount of sunlight, the amount of water amount you give to everything, how you measure it. Your measuring technique, equipment. You could go on and on. Everything else is going to be the same. The only thing you're going to change is maybe the pH, maybe like set up 5 different pH levels. 3, 3.5, 4, 4.5, 5, 5.5, 6. That's more than 3, more than 5. But set up different amounts. Okay. All right. This is in Sweden, a forest in Sweden. We saw Scandinavia. They definitely have a higher sensitivity to this. So acid rain, like all forms of pollution, doesn't stay where it's created. It can move around. And the best way for us to deal with this is pass laws that regulate how much of these sulfur oxides and nitric oxides that cars, trucks, factories can release.